The things that I like most about this section, chapter 1.7, is how it strengthens your ability to understand what's happening to a variable and how you can manipulate equations and write equivalent equations, because we will be moving things across the equal sign, and it's not that we're changing the equation, we're changing the facade, but these are all equivalent equations to each other. So we're going to be solving for y in these first couple of problems. So we want to isolate y. What's happening to y? 2x is being subtracted. The inverse of subtracting is adding. So we'll just add 2x to both sides. And when we write our equations, we're always going to put the variable ahead of the constant. 2 is not a constant, 2 is the coefficient. 15 would be considered the constant. So the constant's always going to go after the variable. We're going to subtract 3x. Don't forget that negative for both of them, or all of them. And now we haven't isolated for y. We have negative y here. We haven't solved for y. We want positive y. So what's that negative sign doing to this y? It technically is negative 1y, and that is multiplying. So the inverse of multiplying by negative 1 would be either dividing by negative 1. If we divide by negative 1, we would have to divide everything on both sides by negative 1. But the better one, at least the ones that I like to do, is we're going to multiply by negative 1. That is also the inverse of dividing by. So we would multiply everything by negative 1. And that gives us y equals positive 3x plus 4 would be y isolated. We're getting y by itself. Let's get rid of the things being added and subtracted to y first. We're going to cancel out that 4x. We get 2y equals 4x plus 8. Now we're going to divide by 2, and we have to divide everything by 2. And I don't mind. You can divide. You can multiply by 1/2. It's probably going to be easier. Oh, Mr. Mac made a mistake. That should be minus, that should be minus, this should be minus. Thank goodness. I checked my work. Nice catch. All right, that one's correct now. So my y is here. I'm going to get rid of that 8. I'm going to align it with the other constant. I get 5x minus 10 equals 5y. I'm going to divide everything by 5. We get x minus 2 equals y, and then I'm always going to rewrite it with my solution first. So if we flip that, you get y equals x minus 2. My y again is on the right side, which is okay. I'm going to get rid of the 7 by subtracting 7. We get 3x minus 6 equals negative 4y. Don't forget that negative, which is attached to the 4. Now I'm going to divide everything by negative 4, and I'm going to get some fun fractions. That's 2 negatives, so that's going to be positive. Did I do that right? Oh yes, Mr. Mac made a mistake on his answer key. That's positive 3 over 2 equals y. And I'm going to write my y first. Y equals negative 3/4 x plus 3/2 would be my answer. Let's make sure, check my answer. Yep, 2 negatives positive. Always reduce those fractions when you can. So that goes over there to fix for the answer key. Isolating y, we're going to get rid of that 8. By subtracting 8, we get negative 1/3 y equals 6x minus 5. I'm going to multiply by the reciprocal, which is negative 3. And I'm going to remember to multiply everything by negative 3. That would give me negative 18x plus 15. All right, now solve the literal equation for x. So we're isolating for x. Well, we can combine like terms here first. So y equals 10x minus 4x is 6x. And then we're going to divide by 6. And we get y over 6 equals x. We can also write that, if we want the variable first, x equals y over 6. Or x equals 1/6 y. I'm okay with either of them. This is more high school answer, but it does mean this, so we should understand both aspects of that. We are still solving for x, so we're going to move that to r. We're going to align it with a like term. We get 4g minus r equals negative 2x. We're going to divide everything by negative 2. We get negative 2g plus r over 2 equals x. I'm okay with that. When we have multiple, and I'm going to write my variable first, negative 2g plus r over 2. Oftentimes when we have multiple variables, we're going to put those in order of alphabetical order. So g comes before r, so g would come first on that right side of the equation. The or could be x equals negative 2g plus 1/2 r. Both of those are okay, but this is the more high school answer. X, we're solving for x, so I'm going to get rid of the 12 first. 3z minus 4 equals 3x minus z. And now I'm going to add z to both sides. That gives me 4z minus 4 equals 3x. I'm going to divide everything by 3, and that gives me 4/3 z minus 4/3 equals x. And I am going to write my solution first. Remember, variables come before constants. The other or could be 4z over 3 minus 4/3. There is no high school, I guess. I'd probably give that. Both are correct. I don't mind either. That's good. I am so, ooh, this is such a good one. All right, so here's the real test. If you got this problem right, then you're looking good. All right, so we're solving for x. So we really can't just solve for this. We can't do minus 9z, because then we'd have x's on both sides of the equation. So my goal is to consolidate those. Well, we can't add them because they're unlike terms. This is x and this is xz. But what I can do is I can factor out, since each of these has an x multiplying, I can factor out an x. If I take an x from 3x, that's 3. If I take an x from 9xz, that leaves me with 9z equals q. Now, see the niceness of this is I only have one x now. And if we can check this, because this times this gives me this, this times this gives me this. And that's what factoring is a form of division. So we're dividing it, we're pulling it out, factoring it out. Now I have the x. What's happening to x? It's being multiplied by this. And how do I get rid of that? How do I move it to the other side? By dividing. The inverse of multiplying would be dividing. So I'm going to divide by 3 plus 9z. And I do it to both sides. 3 plus 9z. And I get q over, I'm going to put 9z plus 3 because, as I told you, variables come before, equals x. And then I'm going to write it with my variable, the thing I'm solving for. That was an ugly q right there. Q over 9z plus 3. That would be my answer. That is such a good question. When you want to get into advanced math, you got to get that problem correct. We again have multiple x's that are not like terms. So I'm going to first move the 4. So I get r minus 4 equals 7x minus sx. So I'm going to factor out an x. If I pull an x from that, I get 7 minus s. check it. 7 times x times 7 is 7x. X times negative s is negative sx. Notice these variables are in alphabetical order, as we had talked about when you have multiple variables. So now I have x times that. I'm going to divide by 7 minus s, divide by 7 minus s. You'll get r minus 4 over 7 minus s equals x. Another really good problem. Now, you will see that answer. I would also be okay with this answer. In fact, I would rather see students write that because the variable is before the constant. And when you rewrite it, you understood this negative was with the s. So we wrote negative s. And 7 was positive, so we wrote positive 7. A lot of students would get that wrong when they rewrite putting the variable first. So me, I like that problem more than, or that answer. All right, x's, so let's get x's on the same side first. We get y equals 6x minus 6. Let's add 6 to both sides. We get y plus 6 equals 6x. Let's isolate x by dividing. And we get y over 6 plus 1 equals x. I'm going to write x equals y over 6 plus 1. That's the high school answer. I'd also expect students to write that because y over 6 is 1/6 y, but this one's better. Good. And you should be able to do these problems this quickly if you are looking to be an above average math student. So solve for b. So we got to get this. What's happening to b? b is being multiplied by h and it's being multiplied by 1/2. So if we want to get rid of the 1/2, we would multiply it by its reciprocal, which is 2. So that gives me 2a equals bh. That's a horrible b. bh. I got rid of the 1/2. Now we got to get rid of the h. The h is multiplying. So we can divide. We don't have to multiply by the reciprocal there. We multiply by the reciprocal of 1/2 because it was a fraction. So you get 2a over h equals b. And I'm going to always write my variable that I'm solving for first. So that is your equation. You're going to keep that a as a capital. You wouldn't write it as a lowercase because it was written as a capital. So we got h again. What's happening to h? Being multiplied by r squared, multiplied by pi, multiplied by 1/3. So when we have that, pi r squared h, and that is the volume of a, anybody know what that volume, oh, yes, hello, of a cone. That was bad. It's okay, Mr. Mack's always thinking. 3v equals pi r squared h. I can divide by pi. I can also include r squared because that's being multiplied. I can do 2 steps at once if you're a good math student. If you're seeing that, how we can extrapolate that out and be a little bit more proficient instead of doing divide by pi and then write that statement and then divide by r, then you'll help yourself. So it's probably easier that way. So hopefully you saw that. And that would be the Ohm's law. Ohm's deals with electricity. So it says I equals VR. I'm pretty sure voltage and resistance. I don't know what I is. Insulation? Maybe that's what it is. Pretty sure Ohm's law deals with electricity. But we're going to solve for R. What's crazy about this is that it's in the denominator. That's kind of crazy. So how do we get it out of the denominator? There's a couple ways. We can multiply by R. That would get rid of it. And R in the denominator and R in the numerator would cancel out. So that gets my R into the numerator. that's a very good way. And now we're still solving for r, so we divide by I. That's a very efficient way. And that leaves me with r equals v over I. The other way you could have done is turned it into two fractions and cross product. But I like that. That's a good one. This one, ideal gas law. I don't know this one. I've never seen this gas law. I have no idea what P, V, lowercase n, uppercase r, and uppercase t. I don't know. But we're solving for r again. So we can do this. So watch this. We got to get rid of the n and the t. So let's do it in one fell swoop. We can be efficient. As long as they're both multiplying, then we can both divide. So r, and we would probably write it, r equals pv lowercase nt. We want to make sure that you're using a lowercase and uppercase when dealing with it. The amount A of money in an account after simple interest has been earned is given by the formula A, total amount, equals P, principal, plus principal times rate, the annual interest rate, times T, which is always measured in years. So solve for R. So we have A equals P plus P times RT. So I got to get rid of this. Now, these are multiplying, but remember, we get rid of things being added and subtracted first. So don't get rid of the capital P and T multiplying the R. Get rid of the P being added and subtracted. So you have A minus P equals big P times RT. Now we can divide by PT because both of those are multiplying. And we get this, A minus P over PT equals R. That is a good way. We could put the PT, this could be seen as this. And then those P's can cancel out because they're being multiplied. So you could see that formula like that. Probably won't see it as much, but that's equivalent to those two. This is fine. You can't cancel the P's right now because they're being added and subtracted. The only time we can cancel something in the numerator and denominator in a fraction is when they're multiplied. So be careful of that. Notice I had to put the PT over the A and then the PT over the negative P, and then I could simplify it because nothing was being added and subtracted in this fraction. All right, so now we get a little bit more information. So now that we have that formula, let's copy that formula because I'm pretty sure we're going to use it. Copy and paste. Let's make it a little bit smaller. So it says the amount of money in an account after the interest has been earned is $1,080. The principal is $1,000 and the time is 2 years. What is the annual interest rate? So it's looking for the R. So we're going to say R equals, so A, that's my initial amount of money, which is principal. The amount of money in the account after interest has been earned. So that's my value, 1080 minus the principal, which is 1,000 over the P, the principal is 1,000 times the time. And it says 2 years. Remember, T needs to be in year, so that's okay. And 1080 minus 1,000 is 80, and 1,000 times 2 is 2,000. And if we simplify that, we're going to make it a rate. So that those zeros cancel. You're left 8 over 200, and 8 over 200. 4 goes into 8 twice. 4 goes into 20, 50, 1/25th, yeah? 1/25th. We could do 80 divided by 2,000. Come on, 1,000, 1,000, 1,000. gives you 0.04. And is that the same as 1 over 25? 1 divided by 25 is 0.04, yeah. So that rate is 0.04. Now that's a rate in decimal form. So decimal form, what is it in percentage form? So 0.04 is 4%. That is the percentage. That's my answer in percentage. Let's see what it says. What is the annual interest rate? Well, I guess you could say either one. I like 4%. That sort of tells me that you understand that it's a percentage rate. And then solve the formula for P. So here we have A equals P plus PRT. Remember, our issue here is that we have two P's and we can't solve for the P. So we want to try to consolidate. Since they're being added and subtracted, we can factor out. If we factor P from P, we're actually left with 1 plus RT equals A. And now we have been able to consolidate those P's. We're going to divide by 1 plus RT, divide by 1 plus RT, and we get A equals 1 plus RT equals the principal. And we'll write it with. And does it use it? Yes, it does. So it wants this equation for the next part. So let's utilize this. Let's group first. Group, copy, and let's look at part D. Part D wants the amount of money in the account after the interest rate has been earned is $885.59. So that is my principal. No, what is the principal? So that is my A is the amount. So that goes in for A. $885.59 over 1 plus the rate is 0.06 times the time, which is 3 years. So we have to convert that percentage into a decimal because you can't multiply percentage. You have to turn it to a decimal or a fraction. So we'll do decimal. 0.06 times 3 is going to be 0.18, I think. And then we're going to add that to 1. So we get 885.59 over 1.18. And we're going to divide that. That I do not know. 885.59 divided by 1.18 leaves us with $750.50. So I got to know that even though it had a 0.5 that I'm dealing with money, $750.50. I'd want to see that monetary going out to the hundredths because it says in the question, what is the principal? That would be my principal. P, I solved for the principal. My starting money was $750.50 and I grew it to $885.59 over 3 years because of an interest rate of 6%. That was compounded simple interest. So very, very simple compounding. All right, number 18. Number 18 says that we have a boat and it averages 30 miles per hour upstream. And on the return trip, the boat averages 35 miles per hour downstream due to the current. The total trip time is 1 hour and 18 minutes. How long does each trip take? So going up, my speed is 30 miles per hour. Going down, my speed is going to be 35 miles per hour. So we talked about this in one of my classes. I don't know how much the time is. I know that this time up and the time back is going to equal 1 hour and 18 minutes. So how much is my time? Well, if up plus down, if we're talking about time, equals 1 hour, 18 minutes. Well, let's see how many hours 18 minutes is. 18 divided by 60 gives me 0.3. So my time is actually up plus down equals 1.3 hours. Now, if I want up, I would subtract from D. So we know that U equals 1.3 minus D. And our objective is we can't have U for time and D for time because that doesn't give us the same variable. So if we use D for downtime, downstream, and instead of using U, we have U in form of D. You see how we were able to use the same variable by using this little piece? That is an advanced math concept. That is something that you would learn in science, as I spoke to, volume. When we have a solution problem, you often see this type of the ability to use only one variable to represent two unknowns. We don't know how long they drive up. We don't know how long they drive down, but we know the total time was 1.3 hours. So using one variable, how can we represent the up and the down time? So we do it in this manner. Now we start plugging in. The distance up is going to be the rate times the time. So our rate is 30 miles per hour. And our time is 1.3 minus D. And downstream, our rate is 35. And our time downstream is going to be D. Now we have only one variable, so that's why we can solve for it. 30 times 1.3 is going to give us 45.5 minus 30D equals 35D. Let's move the variables to the same side. 30D. We get 45.5 equals 65D. We're going to divide by 65, and we get 45.5 divided by 65, which gives us 0.7. 0.7 equals D. And D is the downtime. Time going downstream. And that time is in hours. That's hours. So if we want to find how much of an hour, we do, 0.7 times 60 minutes gives us 42 minutes. So this is equivalent to 42 minutes going downstream, because that's D. So it is 0.7 hours would be okay for down, or what did we say, 42 minutes? Did we say 42? 42 minutes going downstream. So how long does each trip? So we found that one. Now if we want to find the time for going upstream, we would plug it into 1.3 minus D. Our D is 0.7. So 1.3 minus 0.7 gives us 0.5, I think. 5, nope, 6. 0.6 would be our time downstream or going upstream. Time up would be 0.6 hours, or 0.6 hours is going to equate to 0.6 times 60 is going to give me 36. I didn't times it. 0.6 times 60 minutes gives me 36, yes, or 36 minutes upstream. So, That doesn't make sense. Tell me why it doesn't make sense. I made a mistake. Mr. Mac made a mistake. Let's see where he made a mistake. So I know I made a mistake because I'm going slower upstream and I'm going faster downstream, so it shouldn't take me more time to go downstream with the current. So let's go back to our equations. Upstream is 1.3, so upstream plus downstream should equal an hour and 18 minutes. Upstream plus downstream equals 1.3 minus, so upstream, so that's my up, is 1.3 minus D, and downstream should equal D. And did I multiply correctly? Downstream is D, upstream is that. 30 times 1.3, let's see. 30 times 1.3 gives, 39, Mr. Mac. Hello. There's my mistake. That's 39. That's a huge mistake. That is a big mistake. Oh, gotta redo that. I hate making mistakes. I hate when we make mistakes. I'm gonna say 39 divided by 65 is 0.6. Who wants to guess? 39 divided by 65, better give me 0.6. Boom! 0.6, 0.6, which is 36 minutes, which is the time going downstream. My bad. 0.6, 36 minutes. And then if we subtract that, you'll get 0.7 up here, 0.7, and 42 minutes. My bad. Sorry. And that's going to be 0.6. That's going to be 0.7. Sorry about that. Okay. Last two problems. Here we go. So solve the literal equation for C. So what is my problem? My problem is I have C's in here. Not only is Chewbacca in the house, but it's being added and subtracted to other things. So first thing I need to do is get rid of Chewbacca. So I'm going to distribute, which gives me AC plus AB equals XY, alphabetical order, even though I'm multiplying Y times X. I wrote it XY minus CY. So that's good. Chewbacca's gone. Now I have C's that are on opposite sides. So I'm going to move them to the same side. I'm going to add CY. I'm going to add CY. These are not like terms, so I can't combine them. I'm just going to leave them as AC plus CY plus AB equals XY. And now I'm going to get rid of this AB and move it away. Move it away now. Move it away, move it away, move it away now. CY equals negative AB plus XY. So now I have this. Notice my C is multiplying A, my C is multiplying Y, so I can factor that out. If I take a C from AC, it leaves me with A. If I take a C from Y, it leaves me with positive Y, equals negative AB plus XY. AB is always going to come before XY. A comes before X. And now I have this. I'm going to divide by A plus Y, divide by A plus Y, and I get C equals the opposite of AB plus XY all over A plus Y. We cannot, folks, we cannot cancel those A's and we cannot cancel the Y's. Other place students, they will cancel this and they will cancel this, and that is wrong. You can't cancel the A because it's being added to something. So be careful. Do not make that mistake. That is your answer. That is as simplified as you can get it. Cool? Cool. All right, last one. Here we go. Same thing. We're solving for C. So I got c's. I can't cancel any of this stuff. I can't pull it out. It's not being multiplied, so I can't do those types of things. It's in a fraction. So we had talked about this earlier. If I make this a fraction, I can do cross product. So I'm going to multiply these, and I'm going to multiply these. So if I multiply 1 times a plus b plus c, I get a plus b plus c. If I multiply x times c plus y plus z, I can simplify that by distributing. So I get a plus b plus c equals cx plus xy plus xz. Whenever I write a term with 2 variables, it's going to be in alphabetical order. All right, so now we're close. You see where we're getting closer? We have c's. Now we just have to get them on the same side, move everything else, and then factor. So that factoring thing that we're doing in this section is big. So I'm going to subtract a and I'm going to subtract b. So I'm going to do both of those steps at once. That leaves me with c equals the opposite of a minus b plus cx plus xy plus xz. Alphabetical order. Now let's get that cx over on the other side with the other c. We're getting our c's consolidated on the same side. We can't combine them because they're unlike terms. So you have the opposite of a minus b plus xy plus xz. Can't combine the x's because that's xy and xz. Those are different. Now we have the c's and they're being added and subtracted, so I can factor out a c. We get 1 minus x if we factor the c. C from c leaves me with 1. C from negative cx leaves me with negative x. Negative a minus b plus xy plus xz. Now I can get my c by itself. It's being multiplied by 1 minus x, so we're going to divide everything by 1 minus x. C equals the opposite of a minus b plus xy plus xz all over 1 minus x. Now, could you have written c equals opposite of a minus b plus xy plus xz all over negative x plus 1? Sure, that's probably the better. Those negatives do not cancel because they're being added and subtracted. Did I make a mistake somewhere? Uh-oh, let's see. I feel like I made a mistake. Or at least it looks like I made a mistake in my other problem. A plus b. Oh, look at you. Okay, so here's a tricky thing. All right, so oftentimes math doesn't like your first term to be negative, and it happens to be negative on both of those. So we can factor a negative out of the numerator. We can take a negative from each of those. So if I factor out a negative from the top, that changes the a, it changes the b, it changes the xy, and it changes the xz. And we need those parentheses. And if I take a negative from the denominator, from each of those terms, if I take a negative, factor it out, I factor out a negative from the negative x, becomes positive x, factor out a negative from positive 1, becomes this. Why was that beneficial? Because now, since this negative is multiplying that quantity and we're dividing, those cancel out. So my answer could also be a plus b minus xy minus xz over x minus 1. We like this answer because my first term is not negative. Some teachers will still allow you to give that as an answer, but this looks prettier, doesn't it? All right. Oh boy, those last couple of problems were definitely challenging. Good luck with it. Embrace it. Learn it. Practice it. You all have a great day.